Okay, today we're starting chapter 7. This is lesson 7.1. So let's go ahead and take a look at the warm-up. For this first one, I'm supposed to find the measure of x and y. So when you take a look at the x, you have 7x plus 3 here and 3x plus 5 here. Add these three together inside of a triangle and it equals 180 degrees. So that's the way that you would set that up. You would do, let's see here, 72 plus 7x plus 3 plus 3x plus 5 equals 180. Combine your like terms to get 10x. Combine your other like terms to get plus 80 equals 180. Subtract 80 from both sides. You get 10x equals 100. Divide both sides by 10, and x equals 10. Okay, now to solve for y, it's going to be this angle here plus this one. They make a linear pair, so the two of them together equal 180. Now, you have to go ahead and plug in the 3x here. So plug in that x equals 10. So 3 times 10 plus 5. This angle is going to be 35. So now you can add these two, set them up equal to 180 to solve for the y. So that's going to be 35 plus 1 plus 9y equals 180. This would be 36 plus 9y equals 180. Subtract 36 from both sides. Ooh, I'm running out of room. That's going to give me 9y equals 144. Divide both sides by 9, and y equals 16. All right, now let's take a look at the next one. On this one, we're supposed to find the measure of w, x, y, and z. So let me go ahead and set this up here. Okay. Now, you can tell here W, Z, and Y, these are all outside or exterior angles. So let's first address this one inside with X. You would add 59 plus 72 and then subtract that from 180 to find X. And when you do that, you get 49 is X. So this one equals 49. Now you'll be able to solve for y because 49 and y make a linear pair. W and 72 also make a linear pair, and 59 and z make a linear pair. Linear pairs equal 180 degrees. So you're just going to subtract. I'll start with W. You would do 180 minus 72 to find W, and W would be 108 degrees. Now we can do y. You would do 180, subtract 49 to find y, so y is 131 degrees. And then to find z, 180 minus 59, and that's 121 degrees. So that one was pretty simple. Okay, now we're going to talk about polygons. That's a big part of what Chapter 7 is about. Okay, and then it says here that in Chapter 4, you learned that interior angles are the angles inside a triangle, and that these angles add up to 180 degrees. This concept will now be extended to any polygon. Okay, so what we're going to do here is we're going to fill out this chart. You'll refer to this chart several times. That's a good thing why it's on the first part of Chapter 7. Okay, so we're going to take each section here, okay, but this is going to help you. I know you already know that a three-sided figure is a triangle, okay, I know you know that, all right. A four-sided shape is a quadrilateral. Ooh, running out of room. All right, a five-sided shape is a pentagon. A six-sided shape is a hexagon. And again, I know you know some of these. A seven-sided shape you may not know, but that's called a heptagon. An eight-sided shape, I know you all know that, is an octagon. A 9-sided shape is called a nonagon. I know that's strange, but nonagon. And then a 10-sided shape is a decagon. Okay, now the next part of this chart is going to be the number of triangles from one vertex. Now, with a triangle, there's only one triangle inside of that, okay? But this is what they mean. Like, for instance, here's a quadrilateral. That's a 4-sided shape. How many triangles could I make from going from one vertex to another, okay? Well, I can go like this, okay? And that is all I can do. Okay, I can't go over to that side, and I can't go over to that side because that's simply going to be the outside lines of that shape. So the only number of triangles I can get there is going to be 2. Now my next shape is a pentagon. That's a 5-sided shape. That's right there. So the number of triangles that I can make from here, obviously I can't go there, but I can go here from one vertex. I can also go here. Now again, I can't go to there. So from one vertex, I get 1, 2, 3 triangles, okay? My next one's a hexagon, that's this. So from one vertex, I can't go there, but I can go there, okay? I can go over there, and I can go right there. So I can't go here because that's obviously the outside. So how many triangles did I get? And if you see, yes, they're different. This one is obviously a different shaped triangle from that, but it's still a triangle. So that would be 1, 2, 3, 4. Now, I don't know if you already see the pattern here, but as we go on, each one of those would increase each time. Okay, then what you're going to do is you're going to take the number of triangles and you are going to multiply that by 180 degrees, okay? So this, obviously, 1 times 180 is 180. 2 times 180 is 360. 3 times 180 is 540. 4 times 180 is 720. 5 times 180 is 900. 6 times 180 is 1080. 7 times 180 is 1260. And 8 times 180 is 1440. Now, to really totally use these, we will slowly get into that for each one. Now, the next thing you want to do is you want to take a look at how many angles inside a regular n-gon. Now, that N just stands for, is it a hexagon, a decagon, an octagon, okay, that kind of thing. N represents the number of sides that it has, okay? And the number of sides are all going to be right here. And you'll see a little bit more as we progress, not so much with this chapter, but in the other chapters, how you'll use this as far as the sides and the angles. Now, so what you do is you think about how many angles would be in a triangle. That's going to be 3, okay? Because obviously, if you have a triangle, 1, 2, 3 angles, all right? So you take 180 and you divide by 3 and you get 60. And that lets you know each angle in a regular triangle would be 60, okay? And then 360 divided by 4, okay, or a 4-sided shape, okay, is going to be 90. And that's if it's a regular, which means all of the angles are the same. So then we have 540 divided by 5 is going to be 108. 720 divided by 6 is going to be 120. 900 divided by 7. Now this one you actually get a decimal, and that's kind of messed up, but luckily we don't use heptagons as often as we do the others. Okay, the next one is 1080 divided by 8, and that's going to be 135 degrees. The next one is 1260 divided by 9 is going to be 140 degrees. And then last, 1440 divided by 10 is 144 degrees. Now, that's each angle inside. Now, there is a sum of all the exterior angles, and we're going to get to exterior angles in just a second here, but that's the angles that are formed on the outside. And each one of these, and we're only going to write this once, but the sum of the exterior angles is going to be 360 on every one of these shapes, okay? So you will refer back to this chart, or if comes up a question, about a heptagon and you forgot how many sides that is, you can always look through here and it'll have it all broken down for you. All right, so let's go ahead and keep to the lesson here. Okay. Now, this is just telling you here, for any n-gon, in other words, a polygon, okay, the interior angles add up to 180 times n minus 2. Now, don't forget that the n is going to represent the number of sides, okay? So if it's a 3-sided shape, you'd put 3 minus 2. If it's a 5-sided shape, you'd put 5 minus 2, okay? And this is the formula to see what the number, the interior angles add up, okay? So since we know a triangle is 180, let me just show you that example. The number of sides in a triangle is 3. 3 times 2 is 1. 1 times 180 is 180, okay? So that's kind of how that formula will work. But that is for interior angles, okay? So, for example number 1, it says the interior angles of a polygon add up to 1980. How many sides does it have? So what we're going to be looking for is we're going to be looking for n. So the way you approach this question is you just take it up as you use that formula and plug in what you know. All right, well, I'm looking for n minus 2. I know I multiply that times 180, and it's going to equal 1980. Okay? Now, then you're going to take a look at that, and you might be like, well, I don't really know here. How am I going to solve this? How am I going to find n, okay? And the way that you do that is you want to go ahead and do distributive. 180 times n is 180n minus 180 times 2 is 360 equals 1980. And then you just take it like a regular equation, and let's see. That's going to be 2340. Man, they just really did not give me room here. And that's going to be I'm going to put it over here. 180n equals 2340. All right, now divide by 180. And n equals 13. Now that is to decide how many sides, okay? If you're trying to see the interior angles, you would plug in the number of sides and then multiply. But if you're trying to find out how many sides, that's when you have to solve for n. So you just set it up in equation to solve. All right, let's look at the next one. A regular polygon is when a polygon is equilateral. That means the sides are congruent, and equiangular, that means the angles are congruent. So you can see here you have a triangle, quadrilateral, a hexagon, a pentagon, and a hexagon, okay? All the sides are congruent, and all of the angles inside are congruent. Therefore, it is equilateral, that's the sides, equiangular, that would be the angles, okay? So take a look at number 2. how many degrees does each angle in a regular nonagon have? Now, this is where I told you that you could refer to that, that you could refer to the chart, because a nonagon, in case you've forgotten, that has 9 sides. All right, so we're trying to figure out how many degrees. Okay, so the way you would set that up is you would use your formula, 180, and then you would put times 9, that's the number of sides, minus 2. So then you go ahead and do 180, and PEMDAS, of course, tells us to do that parentheses first. 9 minus 2 is 7, okay? So then you take 180, excuse me, 180 times 7 is going to be 1,260. And then you divide that by 9, because that's how many sides it has. And that answer is 140 degrees. All right. So now here is the regular polygon formula, which is basically what we just did. You take 180, multiply n minus 2, and then divide by n. Now remember, n is always going to be your number of sides. So if you're trying to find the measure of each angle inside, this is the formula that you would do. Okay, so let's take a look at example 3. An interior angle, an interior angle in a regular polygon is 135 degrees. How many sides does this polygon have? All right, so you're going to be trying to solve for n. So you're just going to plug it in. 180 n minus 2 divided by n, and that equals 135. So you're just using that formula, okay? Now, how do you solve when you have something like this? I don't know if you've forgotten, okay, hopefully not, but you got to get rid of that denominator first. And the way you get rid of that is you multiply both sides times the denominator. That will cancel out. So here, you'll do distributive. 180 times n is 180n minus 180 times 2 is 360 equals 135 times n is 135n. Now, I'm going to subtract 180n because I'm trying to get my variables together. This is going to give me negative 360. Don't forget that because you're subtracting there. Equals, let's see, and I have negative 180. And let's see. And positive 135, and that's going to give me negative 45n. Now divide by negative 45, and n equals, let's see, 8. N equals 8. So that's how many sides that would have. All right, now here we go with finding the measure of x. Now what you have to do is you have to take a look at, you have each of these angles. This is a 1, 2, 3, 4 sided shape. So you can flip back over to your chart. Okay, take a look at your chart. A 4-sided shape. It is going to equal 360 degrees. The angles inside would equal 360. So that's how you would set that up. You would put 89 plus 5x minus 8 plus 3x plus 4 plus 51 equals 360. Combine your like terms, 5x, 3x, it's going to be 8x, and then you have 89, negative 8, 4, and 51. So when you combine those like terms, you get plus 136 equals 360. Subtract 136 from both sides. 8x equals 224. Divide by 8, and x equals 28. Okay. All right, now, this is exterior angles, like I said just a moment ago, okay? Now, when we go to do the exterior angles, I did not have a colored printer, and the way the lesson was presented to me was with a colored printer. So we're going to number them, but you're still going to get the same idea, okay? So this is how this works. You're going to have, if each of these lines on this shape were continued out beyond the shape, it's going to give you exterior angles all the way around. This is clockwise exterior angles, and this is your counterclockwise exterior angles, okay? And what happens is you have these different angles out here, and what happens is that you end up getting a situation where you would have vertical angles, okay? And so what we're going to do first is we're going to number them. We're going to just go around 1, 2, 3, 4, 5, and 6. And then over here, I'm going to continue 7, 8, 9, 10, 11, and 12. So it gives you 12 different angles, okay? 6 going clockwise and 6 going counterclockwise. And what happens is it gives you vertical and congruent, and you guys all know what vertical angles are, okay? It gives you vertical angles which are going to be congruent. So what I want you to do is I want you to picture this shape. I'm going to try to take off these other things, but notice how angle number 1 and angle number 7, if you look at where they are in the shape, 1 and 7 would actually be vertical angles, because you can tell here where this one is located and where this one is located, how this line goes across the top here. 1 and 7 would actually be angle 1, and angle 7 would actually be congruent to each other. 1 and 7 would be vertical, okay? So now let's keep moving around. 2, and if you look carefully, it's going to be something that goes right here, which would be angle 8. So angle 2 and angle 8 are congruent to each other. Now we can continue on around angle 3. If you look at where angle 3 is, which one would be directly across from that would be 9. So 3 and 9 would be congruent to each other. Let's keep going around. Angle 4. Look at where 4 is. And 10. 4 and 10 would be vertical, and they would be congruent to each other. 5 and 11, notice how 5 is here going down. 11 would meet right up with that right there, and it would be vertical. So 5 and 11 are congruent. And then last, number 6 and number 12 are congruent to each other. All right, and no matter what the shape, it's going to equal 360 degrees, okay? And then what we have next is our exterior angle sum theorem. The sum of exterior angles of any polygon is 360 degrees, okay? So when you take a look at this next one, you have these exterior angles, okay? And obviously it's going counterclockwise, but we're trying to find y. So all you do is you would add 70 plus 60 plus 65 plus 40, 70, 60, 65, and 40, okay? And when you do that, you get, let's see here, $235. So you get $235. All right. Then you take 360 and subtract 235. Now, you don't have to write this out every time. I just think it's a good idea to put it in your notes, okay? And that way when you look at your notes, you'll remember how you got that answer, okay? And that is going to give you 125. So y is going to equal 125. So the exterior angles, doesn't matter if you go clockwise or counterclockwise, the exterior angles add up to equal 360 degrees. All right, now the next one, number 6, what is the measure of each exterior angle of a regular heptagon? Now that's, again, if you needed to, you could refer to the chart to help you keep track of how many sides a heptagon has, but that would be 7, all right? And all you have to do here is, if it's exterior, that's going to be 360, and you're going to divide that by 7, and when you do, you get a long decimal, okay? Always round it to the 10th unless I tell you otherwise. So approximately, you would be looking at 51.4 degrees for the exterior. And that would be an irregular heptagon, because regular means it would be equiangular, so the angles would all be the same. All right, and that concludes lesson 7.1.